So hello dear students, today in this lecture we will learn area and perimeter of two figures. First one is rhombus, parallelogram, and we will also cover trapezium topic in this lecture. So let's get started. Okay, so let's start from uh, rhombus. So do you guys know what is rhombus? Let's start from rhombus. So what is rhombus? Do you know? So simple definition says that two pair of equal and parallel sides, okay, and even all the sides are equal, a closed 2D figure in which all the sides are equal. And second condition is, since the all sides are equal, and uh, we can say it's more like a square, here all the sides are equal and diagonals are not equal. The diagonals will not be equal to one another, okay, diagonals will not equal to one another. So we will cover firstly perimeter of rhombus and then we'll move to area. Perimeter of rhombus and then we will cover area of rhombus. Yeah, so firstly we will cover perimeter and then we'll cover area. So let me first of all draw a rhombus over here. Yeah, let's draw it here. So this is a rhombus, okay, this is what, this is a rhombus, this is a rhombus, okay, fine. So here the perimeter will be, let's suppose the rhombus is named as rhombus ABCD, rhombus ABCD, okay. Here all the four sides are equal, this side, this side, this side, and this side, all the four sides are equal. Let's suppose all the side measure A, the length of all the sides is A, let's suppose. So the perimeter will simply become sum of all the sides, AB plus BC side plus CD side plus AD side. Since all the four sides are equal, which is A and A, so the perimeter become 4 into A, which is 4 into side, which is exactly same as what we had in the square, okay. And now let's cover area of rhombus. So what is area of rhombus? Area of rhombus is basically base into height, okay. What is it? It is simply base into height. So let me first of all draw perpendicular over here. Yeah, wait. Let me draw a line perpendicular to it. Yes. So we will draw a line from a vertex. Let's suppose we are dropping a line from this vertex and will be perpendicular to the side opposite to it. Yeah, it is perpendicular to the side opposite to it. Got it? Yes. Yeah. So this length is, this line is perpendicular to the line which is perpendicular to the vertex BC. Okay, it is perpendicular to the vertex BC. So this is simply perpendicular, and this we say as height. It is height. Okay, and this is base in this case. Okay, this is simply base. This is base and this is height. Okay, so area of rhombus, area of any rhombus is simply base into height. So this is the first formula, and we have got a second formula, which is half into product of diagonals, d1 into d2. d1 and d2 are the two diagonals of this rhombus, which will be intersecting at 90 degrees. Okay, which will be intersecting at 90 degrees. The angle formed between both the diagonals is 90 degree, and they will bisect each other also. Since diagonals are not equal in length, but they will bisect one another. Let me draw two diagonals, straight lines. Yeah. So this is diagonal 1. Yeah. And let us draw another diagonal. Wait. Yeah. Oh no. Wait a minute. Let me draw it once again. I'm going to make another diagonal from the remaining two vertices. Yeah. So here you are seeing that this is diagonal 1 and this is diagonal 2, and they are bisecting each other at 90 degrees. Okay. So here the product of two diagonals will be just halved for the area of rhombus. For area of rhombus, simply you are going to do what? You are going to product the diagonals and gonna take half of the product of diagonals. Okay. And the second formula is base into height. Simply any kind of in any kind of rhombus you can apply this formula, that is half into d1 into d2 as well as base into height. Okay, now let's move to parallelogram. So what is a parallelogram? The simple basic definition says that parallelogram has opposite sides equal and parallel. Are equal and parallel. Opposite sides are equal and parallel. Okay, and the second condition states is, since opposite sides are equal and parallel, diagonals are not equal. d1 is not equal to d2. In case of a square, in case of rectangle, both the diagonals are equal to one another. Okay, but in case of rhombus and perimeter, diagonals are not equal. Okay, got it. Good. So let me draw. Let me see whether there is. Yeah, here it is. Parallelogram. So this is a parallelogram. Let me draw diagonals as well. Yeah. Yes. So you can see that diagonals are not bisecting each other at 90 degrees. They will bisect, but the angle will not be 90 degrees. And you can take a perpendicular line from a vertex to the base. So this line is perpendicular to the base. Yeah, it is now a parallelogram. Okay, and this is 90 degrees. This is what? This is 90 degrees. Yeah. And diagonals, let's suppose this is diagonal 1, this is diagonal 2. We have named them as d1 and d2. Okay, and this perpendicular line drawn from vertex A 2 point, let's suppose it is E, is perpendicular to the base. This is base, okay? This side we are taking as base. Fine? Yeah. So it is parallelogram ABCD. In parallelogram ABCD, the base is CD and the height is AE. Okay? Yeah, good. Let's suppose this length is, let's suppose it is A. So this side will also be A since the opposite sides are parallel and equal as well. Opposite sides are parallel and equal. This side is equal to this side and also parallel. These sides are, for parallel we draw arrows, and for equal we simply make lines crossing over the sides. Okay, yeah, here you can see that the angles is not 90 degree, but in this case here the diagonal were bisecting each other at 90 degrees. Got it? Yeah, so this is a parallelogram, and let's suppose the length AD is small b, so side BC will also be small b because opposite sides are equal and parallel. Yeah, so in case of perimeter, we are simply going to add all the sides. I have already told you that what is perimeter. Perimeter is simply sum of all the sides. Sum of all the sides in any closed figure you see. You are simply going to add all the sides present in that figure. Okay? Yeah, fine. So AB plus BC plus CD plus AD. Here we have added all the sides AB plus BC plus CD plus AD or DA. We have added all the sides. Okay. So here the AB length was A, and BC length was B, CD length was A, and BC length was, and AD length was B. So here you are seeing that it becomes 2A plus 2B, which is similar to rectangle. Okay, which is similar to rectangle. So you can take 2 common over here, it becomes twice A plus B. But simply, if you remember that perimeter is simply sum of all the sides, so you will not need formula as well. Initially you have to learn formula, but when you grow up, your maturity level increases, you simply wanna calculate those things in your mind by just imagining figures, square, parallelogram, all those figures you are just going to imagine in your mind and make formula by your own without learning any kind of formula. But this thinking process will be developed with a period of time. So for that you have to firstly go through all those things which I'm mentoring you to do. Yeah, this is perimeter, and for area we have simply the formula base into height. Area is simply base into height, which is exactly similar to what we had in rhombus. Base into height. Here is also base into height. Okay, here is also base into height. Here is also base into height. It is also base into height. Yeah, fine. So base is what? Base here is CD into height is A. In figure you are saying that base is CD and height is A. And here if you see, so base is, like base we have taken as BC and height is simply H, or you can even name this point as P, so it will become AP. It will become AP. Since it is taken from point A, that's why it will become AP. It will become A to P. This point is P. Okay, so let's now move to, so far we have covered area parallelogram, perimeter parallelogram, perimeter of rhombus, as well as area of rhombus. And now we will cover what? We will cover trapezium. I hope that you are enjoying my lecture. So we are covering trapezium. So what is trapezium? Trapezium definition is simply one pair of parallel sides. That's it. A quadrilateral with one pair of parallel sides. A quadrilateral with one pair of parallel sides. Simple. Let's make a pair of parallel sides. It is a little bit difficult to draw shapes using pen tab, but still I'm doing my best to make figures. Yeah, let's suppose this is a trapezium. It is trapezium. So this side you are saying is parallel to this side. So we have got a pair of parallel sides. It is a quadrilateral since it has had four sides. Because it is having four sides, so it is a quadrilateral. Quadrilateral ABCD is what? Trapezium, because it has got a pair of parallel sides. The remaining pair may not be parallel or may be parallel. It isn't matter of concern for us. It is not a matter of concern for us. Simply the definition states that the quadrilateral must have one pair of parallel sides. Other pair may be parallel, it will be good. Not be parallel, it will also be good. It doesn't care at all. Okay. Yeah. So here in this case, let's name them. Let's name the side AB has got measurement A. What is this? Yeah. Yeah. So let's name the side as small a. This might be B, this might be C, and this. Let it be D length. Okay. So firstly, perimeter is going to be what? For perimeter, you are simply going to sum all the sides present in this quadrilateral, which is AB plus BC plus CD plus AD. Okay. AB plus BC plus CD plus AD. AB is what? AB is a small a. BC is what? A small b. CD is what? A small c. AD is what? A small d. So here you have got the perimeter as a plus b plus c plus d, or simply sum of all the sides present in the trapezium. Okay. So let's for area we have to simply draw a perpendicular from the opposite vertex. Let's suppose this is a perpendicular line from it. Let's name this as P, since we have already used D, so it will be P. Okay, fine. So it is a height, it is a perpendicular. It will take time to draw it using lines. That's why I have made a rough sketch. You understand it as perpendicular line to side CD. Okay, you understand it as perpendicular line to CD. This is height in this figure. For area of trapezium, what we are going to do is, what is the formula we have got for area of trapezium? For area of trapezium, the formula is half into sum of parallel sides into height. So using this figure, if I ask you to substitute the values, you'll be putting the sum of parallel side as first parallel side is AB, second parallel side is CD, into height is simply H, or it is AP. So this is the formula we will use in trapeziums. So let's do a question. That find the area of a trapezium with parallel sides measure 6 meter and 10 meter respectively, and distance between the parallel sides is, let's suppose, 4 meters. So for this question we have to simply draw a rough sketch. First of all, we are supposed to draw a rough sketch. So this is a rough sketch of a trapezium. So this parallel side and this parallel side have got measurement given, which is 6 meter and 10 meter. We have to drop a perpendicular line to the base. Okay, this perpendicular line will be the distance between the two parallel lines. It is the distance between both the parallel lines which is given. So indirectly it is height given in the question. Indirectly it is the height given in the question, which will be h. So this is simply h. This is simply a perpendicular drawn from the opposite vertex to the base. Okay, so use the formula. Area of trapezium is half into sum of parallel sides. So the sum will be parallel side have got the measurement 6 meter and 10 meter, and we have to multiply it with height. Height has got the value 4 meter, so it will be 4 meter. So it becomes 1 by 2 into 16 into 4. 2 cancels 4 2 times, so it becomes simply 32 meter square. So this is the area of the trapezium. Hope you understand the lecture. We can take another question as well.